Alright, so here we have a basic gravitation example here using Newton's universal law of gravitation. I asked what's the average gravitational force between the Earth and the Moon. I have to give you some values here as well. I said the average distance between the Earth and the Moon is 3.8 times 10 to the 8th meters, so a slight change there. Once again, the average distance between the Earth and the Moon is 3.8 times 10 to the 8th meters. Now, this is important to note that that's the average distance between the two centers of those objects. So we're going from the center of the Earth to the center of the Moon. Some other things, we know that gravitational constant is 6.67 times 10 to the negative 11th. The units on that are newtons, meters squared over kilograms squared. We won't go into the derivation of that, but those are the units for that particular constant. We have the mass of the Earth is 5.98 times 10 to the 24th kilograms, and the mass of the Moon is 7.4 times 10 to the 22nd kilograms. So, all I'm asking is the average gravitational force, and the reason why it's average is because the Earth and Moon are not always the exact same distance from one another. That 3.8 times 10 to the 8th just so happens to be the average distance between those two. So what we need to do is use our equation F, meaning force of gravity, let's put a little subscript g there, is equal to big G, that gravitational constant, times the mass of the Earth, that's m1, times the mass of the Moon, m2, over the radius, meaning the distance between those two objects' center, squared. So we'd have force of gravity, we're just plugging things in now, is equal to 6.67 times 10 to the negative 11th times the mass of the Earth, 5.98 times 10 to the 24th, times the mass of the Moon, 7.4 times 10 to the 22nd, and remember all those are in kilograms, over the radius, and our radius is in meters. That would be 3.8 times 10 to the 8th meters squared. We go through, evaluate that mathematically, and we get a force of gravity equal to 2.04 times 10 to the 20th newtons. And that is, once again, a mutual force of attraction. What do I mean by mutual force of attraction? That means that, hey, the Earth is exerting 2.04 times 10 to the 20th newtons on the Moon, and the Moon is doing the same thing to the Earth, but in the opposite direction. So those are being pulled towards one another at all times. So my next question is going to be, for part 2 here, let's start a new page. I have to figure out how to do that. Let's go new page. I'm going to also ask, what is the acceleration of the Moon? So part B, what is the acceleration of the Moon? Well, all of you should be saying, hey, that's going to be really, really easy. If I go through and draw a little diagram here, let's go Earth. Boom. Moon is going around in a relatively circular orbit. We would look at, here's going to be the Moon. I'll just draw that as a little dot. We remember that anything undergoing circular motion, that centripetal acceleration, always acts directly towards the center, and then if we were to draw that tangential velocity, that would be acting at a line tangent to that circular motion. So we look at that. I just solved for a force in the previous problem, and we know everyone's favorite equation, F equals m times a. So we look at that, we'd be looking at the force of gravity is equal to the mass. I'm asking for the acceleration of the Moon, so I'm going to look at the mass of the Moon times the acceleration. So we get A is equal to Fg over the mass of the Moon. which is equal to 2.04 times 10 to the 20th over, wow, that's a bad line, 7.4 times 10 to the 22nd. I go through, evaluate that mathematically, and I get a very, very small centripetal acceleration of 0.0028 meters per second squared. So we relied on an old friend, F equals ma, and then found the acceleration of the moon. There you go, is a very basic, very simple gravitation example.